Welcome to the constant velocity challenge question number 3. Here we have two cars that are 20 meters apart. Car A is at 3 meters per second and car B is at 6 meters per second. Let me just draw something here. Alright, so if you've already looked at the question, part A is different than part B. So I've just drawn something here just for part A here. And this is the cars are facing each other. And if they're 20 meters apart, so what I've done is make this the origin, the front bumper of car A in my excellent drawing. And so the other one is 20 meters apart, so this would be 20 meters here. Find the time and the position where they meet. So we did something very similar to this in class. So I'm going to make statements for each of them. I'm going to say, all right, so the mathematical model for car A, the position of car A at any given moment is going to be, well, its velocity, which is 3 meters per second, multiplied by how many seconds have gone by. Now they start from the origin, so we're done. That's all. We don't have to say plus or anything. So for car B, now they're going in the negative direction. So it'll be minus 6 meters per second times how much time, but they started at 20. All right, so now we're going to equate those two. When they meet, they're going to be at the same position. So I took this piece and put it there, and I took this piece here, put it here. I'm going to say those two are equal. And so now when I solve for time, I guess I need to add 6t to both sides. So I'll get 9t equals 20. Solving for t, I will get, well, 20 over 9. I could actually leave that, or I could put it into decimal form, so that'd be 2.2 repeating seconds. So there's my part for time. But then we also want to figure out not only the time, but we want to figure out the position. So we can use either one of these formulas. I'll use the first one here. I'm going to say, okay, this one will be at 3 times my, I use my 20 over 9 because then I don't have to worry about all those decimals. And then I get 6.6, 6 and 2/3, or 6.6 repeating meters. I can also do a check with my other one and say, does it work out the same? So where will car B be at that point? Well, it's minus 6 multiplied by our 20 over 9 plus 20. And when I multiply that out, I do actually get the same thing. It will be at that 6.6 repeating meters position. So there's my answer. That's my answer for part A. I'll separate this and say, okay, now let's take a look at part B. So part B, they are facing the same direction with car A ahead of car B. All right. All right, so here's my really fancy drawing. You notice I had to make sure that I put car A in front of car B because car A is the slower one. So if we're going to do the question about, when will they catch up? When will they meet? Then I got to make sure I put the slower one out front. So this is 0 again, and then this is at 20. And so we can figure this out. We can say, okay, the equation, I'll do car B first. Now it's going positive direction times time. And it starts at the origin. So for car A, I'll go for the blue here. Car A, it's going to be going 3 meters per second times the time plus 20. So the question is, when will they meet? So those two are going to be equal to each other. So I'm going to write 6t. It's going to be equal to 3t plus 20. So you'll notice in this case, instead of adding together those t's, I'm going to be subtracting. So I get 3t equals 20. So the time will be equal to 20 over 3 seconds. Or I could, write that as, what is that, 6.6 repeating seconds. What will the position be? So I can take the first one here and I'll say this one will be 6 times 20 over 3, which would be equal to 40 meters. Yep, and for A, it will be 3 times 20 over 3 plus 20, and again, so these will cancel out, so I'd get 20 plus 20 would be 40 meters. So where will they meet? They'll meet at 20 at the time of 20 over 3 seconds at position So the time is this, and the position will be at 40 meters. All right, so I hope that helped. Thank you very much.